All right, ladies and gentlemen, next one, lecture 4, is about bases and the strength of bases. So they work the same way. So if it's a strong base, you still have a stoichiometric problem there. So group 1 hydroxides and group 2 calcium and below hydroxides are the ones that we're most worried about. Those are the strong ones. Those are the ones that we consider when we're talking about strong, because they dissociate completely. Weak are based upon KBs, just like we were based upon a KA. So a KB is the opposite of KA. It's the base part of it. So these are KBs because they're bases. The bigger the KB, the better the base. Some bases may not be on there because they are conjugates of weak acids. So if it's a conjugate of a weak acid, to find its KB, you find the Ka of the weak acid, and then you do the calculation. Remember the calculation? Hang on just a second, and I'll get it up here for you. Kw is equal to Ka times Kb. Okay, so you just rearrange that equation to find the Kb. You take Kw divided by Ka. So if they're not on the Kb list, go to the Ka list, find the acid, the acid that is the conjugate of it. Okay, so the acid that makes that conjugate, and then you do the calculation using Kw. All right, so here we go. Strong base. Find the pH of 5.0 times 10 to the negative second molar NaOH. Now, this is dead simple. So there are two ways to do it, and this line should be down a little bit. So first of all, we could take the concentration of the, oh, that's interesting. So this one I like, this one is the one that I would do over here. This is the one that I would choose because it makes the most sense to choose that one. So here we go. This way is just kind of rigmarole from the Kw, or the concentration of the water and the concentration, and then you're basically using that idea of the concentration of the Kw for the water, and you're working backwards through that. I prefer this way right here. This way makes more sense to me. So I find the pH by taking the negative log of the concentration of the, the pOH by taking the negative log of the concentration of the OH, because it's a 1-to-1 situation here. And I find that that's 1.3. I take 14 minus 1.3, and I get 14 minus 1.3 gives me 12.7. So that's my pH. Okay, that's the way that I like to do it best for me. Okay, this one produces the same exact result. If I take the Kw concentration and divide it by the concentration of OH, I get the concentration of H in there, and then I can put that in and I get the same exact answer. So that's basically what it's doing. It's just using that Kw is equal to Ka over Kb. All right? There's no one-time rule for bases. So in this particular situation, we have 3 molar CaOH2. Well, because there are 2 OHs, that's 6 molar right there. Okay, so the pOH is right there, and we see what the pH is. Yeah, you can have pHs higher than 14 as well. Okay, lower than 0, higher than 14. It all has to do with the concentration and that calculation, okay? So here we go. Some don't have OH but still produce them. So here we go. This is one that doesn't have OH but still produces them, NH3, right? So what do? We know that the Kb is equal to this. So that's the equilibrium constant. If it makes OH, you have to use Kb instead of Ka because it made OH, okay? To find the pH of 15 molar NaOH, so we set up an ice table. Here we go with the ice table. There it is, and we get all of this information, but because the change right here is very small, we can negate that, and we can solve for it, and notice the 5% rule is 0.11, so we get a pretty good thing there. So the pH is 1.8, so the pOH is 1.8, and the pH is 12.2. We just subtracted from 14. Guys, this is the same stuff we were doing with the acids. It's the same stuff. All we're doing is we're using bases and Kb. K K is the equilibrium constant. The letter that goes with it describes what we're talking about specifically. So Kp is pressure, Kc is concentration, Ksp is solubility, Ka acid, Kb base, Kw water, and we know the value for Kw all of the time at 25 degrees Celsius at least, okay? So find the pH of 1 molar solution of methylamine. We see the Kb. There's the Kb for it. It's given us that. So here we are. Ice table time. Looks like that seems to be pretty small. It's times 10 to the negative 4, so we can probably negate that guy and just solve. And we get this answer over here. So we see the POH. We see the concentration of OH, right? Put that in. It's 2.1%, so that's within the 5% rule. We have 1.6 POH, we subtract it and we get 12.13 pH. So this is all the same stuff that we've been doing. We're just doing ice table stuff, okay? So a solution of triethylamine has a pH of 11.55. Find its initial concentration. If the Kb is 4.0 times 10 to the negative 4th. So it gives us an answer here, but let's see if we can figure out what the answer should be. So remember, we set up an ice table, so we have trimethylamine. It just means 3 of those with this guy, plus H2O, and we get an equilibrium expression, and we get this triethyl thing here with a positive plus OH, yes. So then we set up ice. All right, so we don't know the initial concentration because that's what we're looking for. We don't know this. We're not going to worry about water. We know we're going to minus X here. Okay. We know over here that we have 0, 0, X, and X. Okay. So we have question mark, minus X, X, and X. Okay. So everybody good with that so far? Any problems so far with that? We just set up the ice table. All right. So let me erase real quick. All right, so we set up the ice table. We've got some information from the ice table. All right. This is the problem erasing, because if I don't touch every little bitty thing, I don't erase very well. Okay, so now we know some things. So we know that the Kb, I'm sorry, I've got my eraser still on. Hang on, let me go back. Now we know that the Kb is equal to X squared over question mark minus X, right? That's what we know. But we have the pH. We have the pH. So that means we also know the POH, right? If we have the pH, we know that the POH is 14 minus 11.55. That means that the POH is 14 minus 11.55. That means the POH is 2.5. So if we calculate backwards, we can get the concentration of OH. The concentration of OH is 0.0035. Okay, so that's the concentration of the OH. So we know now, hey, we have 0.0035 squared over some number, question mark, minus 0.0035. And we know what the Kb is. We're given the Kb. So there we go. So now we plug in everything. And what we end up getting when we plug everything in, so the Kb is also equal to 4.0 times 10 to the negative 4th. So I can basically erase all this stuff right here that gives me the work. And these things are equal to one another now, okay? So then I start calculating and I find out that my question mark concentration is 0.032 molar. And that's what we got. So, yep, we got the same answer as what you were supposed to get. So, that's how it works, ladies and gentlemen. It's the same thing as equilibrium. So just, keep trucking. All right.